and 11 of programming with C++. Now, in today's week, we'll be looking at operator overloading and derived classes. So let's just get right into it. So, first of all, what is operator overloading? Now, operator overloading lets you define how operators. Okay, we know what operators are: addition, subtraction, multiplication, etc. Right? It defines how these operators work with your own custom classes and objects. Right? And normally these operators only work with built-in types like int or floats, but with overloading you can also make your operators work with your classes too. So why should we use operator overloading? Well, basically it makes our code more intuitive, right? That is, you can write object one plus object two instead of object one dot add, which is two, right? Like in our week 9 video where I was adding the sum of two numbers, right? Then you see, I after creating the object, I created an object of a class in that video, right? The object was called calc. Now, in order to perform the addition, I had to write this down. That is calc dot I think it was get sum. Yeah, calc dot get sum. Calc dot get sum. Right. So instead of doing that with operator overloading, you can just do object one plus object two. Okay, you can just introduce the operator over the plus. Okay, so it makes basically makes complex operations look simpler, right? Like, see what the example I give. Okay, the week 9, what I did, right? It was quite complex, but with operator overloading, you can just make it very simple. So, let's look at the okay. Here are some operators. I don't really need to show you this because you should know this by now. Logical operators, arithmetic operators, relational pointer operators. Yeah, these are. And then, okay, yeah, I forgot to mention there are types. Okay, function overloading and operator overloading. Okay, so for the operator overloading, this is the syntax. This is the syntax. So the syntax is your return type, your operator, and then your symbol, and then your parameters. Okay, let's see what each of these mean. Return type is basically your data type, right? And then the operator is a special keyword, and your symbol is the operator symbol, whether it's being the plus, minus, or whatever. That's your symbol, and then your parameters are defined in the function, right? Parameters are still parameters we did in functions now, so that's it. So here's an example of operator overloading. Let me demonstrate it. So your return type, that is int. In this case, for me, int your return type, then operator, a keyword, okay, then your symbol. I'll use plus. Sorry, I'll use plus. Then your parameters. Okay, so let me just do this here. Parameter. Let me comment. Yeah, so I think this basically it. Right now, let's see. You can also write what you want to happen if like the statement. You can add a statement, right? Maybe the line of code that will be executed when the conditions are met. So in this case, for this example, the parameter was int age, right? And then he wants to increment age, right? Wants to increment age. This code will not work because the person did not define age, right? The person don't define age or give age a value or initialize age. So since the person didn't do any of that, this operator overloading will not work. Okay, so that this is basically the structure. Okay, so your return type, your operator keyword, then your symbol, then your parameter. Yeah, and if you like, you can introduce your statements, right? Or whatever you want to have in your curly braces, right? So maybe Um, okay, since I didn't bring any parameter, okay, okay, fine, let me just bring a parameter. Just bring a parameter. Okay, so int a comma int b. Okay, so then I can have my um statement here. So return a plus b. Okay, return a plus b, right? So this is basically operator overloading, right? Or you can also decide to include, but if you want this code to work, we should first define, we should first, sorry, initialize A and B, right? Or yeah, okay, sorry, for this code, we don't have to initialize anything. But for the increments code, okay, yeah, I don't, you don't, okay, I think I'm wrong. You don't really have to uh initialize anything. You can do all that when you are accessing the thing, right? So when you are uh, defining or trying to access the thing in the local scope, yeah, then you can do that. There you can uh since you have parameters here, you can pass arguments in the local scope to cover that. Yeah, you don't really have to initialize anything. So that's operator overloading. So there are some forbidden overloading rules we need to know, right? So we cannot overload these operators, right? So the ternary or conditional operator, we can't overload it. The scope resolution operator, we cannot overload it. The dot operator, we can't. The pointer to member operator to, we cannot. The object type operator as well. The object size operator, that's the size of, we also can't. The object alignment operator as well. Then only existing operators can be evaluated. Yes, only existing operators can be evaluated, and then new operators cannot be created. Only built-in operators can be evaluated, and also existing operators cannot be renamed. So something like plus cannot be renamed. Something like minus cannot be renamed because they already exist, right? And at least one of the operands overloaded operators must be user defined. Yes, so that is the forbidden overloading rules, right? Okay, hey, there are many. Okay, it's not possible to change the number of operands of an operator supports. Hey, it's not possible to change the number of operands an operator supports. Yes, I think that's supposed to be it. It's not possible to change the number of operands an operator supports, and also the default precedence and associations of operators are maintained. Yes, we did order of precedence in our earlier videos, right? Where you have your brackets coming first, like board mass. So your brackets operators are considered first, as well as your division, multiplication, and modulo. Division, multiplication, modulo, right? They have the same precedence, so any of them can be considered first. Before you come down to your addition and subtraction as well, they are the they have the list, or they are the list, or the the last things you do. Then let's move on to operator overloading. That is the advantages of operator overloading. It simplifies the syntax, right? So it allows the use of notation closer to the target domain, and consistency as well as easier understanding. Those are the advantages of operator overloading. Provides consistency and easy understanding. And then the disadvantages are um, the complexity, right? So overuse or misuse introduces complexity, and limited overloading as well, because not all operators are overloaded. So those are the advantages. Disadvantages. Then let's go on to derived classes. So derived classes are created from an existing class, right? and they are created from an existing class, or it's a class that inherits from another class. Okay, it gets all the attributes and methods of the base class and can add its own. So why use inheritance? Well, um, derived classes are basically based on the concept of inheritance. So, and I say why use the inheritance. I mean, why should we use derived classes? Okay, so it avoids code duplication. That is, reuse existing code, and then it creates logical hierarchies. Okay, so maybe for instance, you create a base class called animal. You can also create a derived class of that base class called dog. So there's like a logical hierarchy, right? A dog is an animal. So and also it supports polymorphism, right? That is many forms. Yeah, polymorphism means many forms, right? Many forms. So how do we create a derived class? What is the structure? Okay, so you first create a base class, right? You first create your base class. So after creating your base class, then you follow this syntax over here, right? So class, the name of your derived class, then a colon, then the access specifier of your base class that you created, right? So let's say I created a base class with the access specifier public. I'll come down here when I'm creating my derived class. I'll create first of all name my derived class. So class, let's say I create a base class called animal, right? So class animal, right? So I'm creating a derived class. I come down and I do class dog, okay? Class dog, then a colon, then the access specifier of my base class called animal. So in this case, the access specifier of the base class animal was public. So public, then animal, right? Don't worry, I'll demonstrate it in the code blocks so that you get a clear understanding of the structure. Then within the rest is basically the same as the base class, your access specifier, your attribute, your method. So that is the basic structure of a class, right? Let's go on ahead to demonstrate that. Okay, so let's see. This is my code blocks now. Let me. So all this will be done outside again. So I create my base class for animal, right? Animal. Then it is public. Oh, sorry, it's public. And let's see. It's public, and then over here I have uh void eat eat. This is my method. The method for my base class. Okay, eat. Then void void. Let's see. Sleep sleep sleep. Okay, so I've created my base class. As you can see, I've created my base class. Okay, so if I want to create a derived class, I will just hold on. So I'll just come down here again, then I'll create my derived class. So class dog is the name of my derived class dog, then a colon, then the access specifier of the base class that is public, then the name of the base class that is animal. Then I do this, come down here and we once again identify the or include the access specifier of your derived class, then your method as well. That is if you want to. So in this case, let's say back. I mean dogs back. So yeah, back. Yeah, yeah. Okay. So that is basically how you create a derived class from a base class. So yeah, you can verify from this example, right? Uh, you created a derived class, right? From the base class you created called my record. Okay, it didn't really show here, but in the previous, if you've been following the videos so now, you know that we created a base class called my record when we were doing classes, right? So he has created a derived class from that base class, right? And I've also created one here, my very own, that is um animal, right? Then my base class is animal, my derived class is dog, okay, from animal. So let's yeah, let's move on, let's move on. Okay. So derived class using access modifiers, derived class using access modifiers, right? So uh for public, the base class members keep their original access. For public, the base class members they keep their original access. For private, the all the inherited or all the derived class members become private. For private, all the derived class members become private, and then for protected, all the public members become protected. But then, I think the private still remains. Yeah, the private still remains. Let me see. Yeah, public. The members of the base class are inherited by the derived class just as they are. Uh-huh. And then for the privates, all the members of the base class become private members in the derived class. And then for protected, the public members of the base class become protected members in the derived class. But the private members of the base class are always private. Yeah, so the private is not affected, right? So for the public, they remain the same in the derived class, right? And then for private, if it was public in the base class, it will become private in the if you declare the derived class as private, the public members will now become private, right? Yeah. And then for protected, the public members become protected in the derived class when you declare them as protected. But then the private still remains private in the derived class. But if the members that were in the base class were declared private and then you declare them protected in the derived class, they will remain private, they will not change to protected. But then if they were protected in the base class, they will change to protect they were public in the base class, they will change to protected. Yeah. Let's move on to inheritance. Inheritance. So inheritance allows one class to reuse attributes and methods from another class, right? So we have the derived class and then the base class. That is the type of inheritance we have. So the derived class we've gotten to know what derived classes basically are, and as well as base class, right? So they also allow us to create new classes from existing classes. Let's look at the flow process of an inheritance. So inheritance. Yeah, I've even done this in code form. This is a flow chart form, but the code form is also here, right? Where we have our base class being animal and then our derived class being the dog. Over here as well, we can see they've done something similar. Our base class here was animal, our derived class was dog. So yeah, and this is an inheritance code. This is basically what I just did, right? This is basically just what I just did or demonstrated in my code blocks. So I'm not going to do that again. Then we have types, right? We have single inheritance and hierarchical inheritance. So for the single inheritance, we have the multi-level inheritance, right? So the multi-level inheritance, okay, you let's take one after the other. Okay, let's start from single inheritance. Okay, single inheritance. So single inheritance is basically one base class to one derived class. So as you can see the diagram, one base class to one derived class, and then is multiple base classes to one derived class. So over here we have two base classes mapping to one derived class. Then we have um multi-level, yeah, multi-level, where the class inherits from another derived class, right? So the multi-level, where is it? Here. So we have um a base class, right, inheriting from or a class inheriting from another derived class. So we have a base class here, right? Then the second base class is inheriting from the first base class, and then the last derived class is inheriting from the second base class. And then we have the hierarchical inheritance. It's basically a combination of all. It's basically a combination of all. You can have a single base class. Hey, sorry. Uh, that is not for the hierarchical. Okay, hierarchical is one base class to multiple derived classes. One base class to multiple derived classes. So um, we have one base class mapping to multiple derived classes. Now hybrid is rather the combination of all. Okay, so you can have one base class mapping to one derived class, one base class mapping to two derived classes, one base class um inheriting from another base class, and a derived class inheriting from that base class as well. So it's a combination of all the above we've mentioned. Now we have our inheritance rules, right? Where the rules state that static members are class dependent and are not inheritable. That's the first rule. Friend classes are not inheritable. So they are showing you the kind of members and classes that are not inheritable, right? Yeah, basically you cannot create you cannot create a new class for these kind of things. So that's what I'm listing, right? Static members are class dependent, they are not inheritable. Friend classes are not inheritable. Constructors and destructors are not inheritable. Now let's move on to polymorphism. Once again, polymorphism meaning many forms, and it occurs when we have many classes that are related to each other by inheritance. So they use methods inherited from another class to perform different tasks, right? So this is the polymorphism code. There's a polymorphism code. This is the basic polymorphism code, right? There's nothing special. It's whatever we've done. Okay, so over here, the person created a class, or the user created a class, a simple class, a simple base class. The class is called my record, right? It's a public class. Uh, the attributes is my age. The method is get age, right? This is a simple code. Now this is where the polymorphism kicks in, right? So we created a derived class called group D record, right? And then over here we can see that um we can see that the base class member has been redefined in the derived class. Okay, the base class member function has been redefined in the derived class, so we can see that over here as well. So that is all for week 10 and 11, right? That's all for week 10 and 11, and that this is the final video as well. So thank you for your time, and yeah, you meet later on.